Hi, my name is Peter Resnick, and today we're going to explore how to securely and effectively create a SageMaker Notebook instance to enable efficient data science development. We'll cover topics around lifecycle configurations, Git repository attachment, VPC attachment, and more. We're here in our AWS Management Console homepage. Let's go ahead and navigate to the SageMaker service by searching for it in our search bar and selecting it. Awesome. We're at our Amazon SageMaker Dashboard, where we can see all sorts of information regarding what the service has to offer. From labeling jobs, to notebook instances, to training and more, there are many options to choose from. We'll focus on our notebooks. We can see on the left-hand side that we have a few subcomponents available under our notebooks category: notebook instances, lifecycle configurations, and Git repositories. We're going to focus on notebook instances, but let's also discuss lifecycle configurations and Git repos. We can use lifecycle configurations to perform a number of tasks for us as users. If we want to install packages or sample notebooks into our instance, configure networking or security, or leverage any shell scripts to further customize our notebook, then we'd want to use a lifecycle configuration. Lifecycle configurations can also help us access AWS resources, such as Amazon EMR, directly from our notebook. There are a number of examples that can be viewed at the AWS-samples GitHub repository. Let's go ahead and quickly take a look at what it would require to create and apply a lifecycle configuration. Once we select lifecycle configurations, we see that if we have existing configs, they may be here. In this account, we have no existing configurations. So let's create one. This will bring us to a new page that allows us to name our config and subsequently define the script that will run. Let's name it SageMaker Demo Config. Let's take a look at what it would require to create and apply a lifecycle configuration. We can select Start Notebook or Create Notebook as the two options for our scripting execution. As you may expect, any code that is placed below the Start Notebook section will be executed when the notebook instance is started, including the initial creation. This will be run each time a notebook is stopped and restarted. Conversely, anything placed under the Create Notebook section will only be run during the initial creation process. It will not be run during subsequent startups. For example, let's say we wanted to set some Git configuration parameters. We could handle that here in our notebook startup by updating the notebook to include a set of executable lines that configure our Git environment appropriately. Let's copy and paste some existing code into our AWS environment, and just like that, we have a lifecycle configuration. Let's create it. Awesome. We now have a lifecycle configuration to add parameters around our Git configuration. Let's move on to Git repositories. If we select this subtopic on the left from under our Notebooks pane, we are taken to a page of all available Git repositories within our account. And would you look at that, we've got none. Let's adjust that by adding our repositories to our SageMaker service. Once we click Add Repository, we're taken to a new page that gives us a few fun options. We can either add an AWS code commit repository, or we can add another Git-based repository to our SageMaker service, which will manage the accompanying credentials using AWS Secrets Manager. If we choose to add a repository using code commit, it's quite simple. Just decide whether or not we want to use an existing repo or create a new one. If we want to use an existing repo, we can select it from our dropdown here. We don't have any in this account. If we want to create a new repo, we can create and name the repo right here in the SageMaker service. Let's select Create Repository. We'll need to provide it with a unique name in both the account and the AWS region. Let's name it Resnick Demo SageMaker New Code Commit Repo. Quite extensive, but should be unique. Let's create it. Success! We've created our code commit repo, and we can even add it right from here. Awesome! Amazon SageMaker now has associated Git repositories. let's add another repository. This time, let's explore adding a GitHub repo. We'll have to fill out a few more parameters before we can add this one, but it's still quite simple. Let's give our repo a name that SageMaker can utilize. Let's call it SageMaker Demo Repo. Next, let's drop in the URL of our Git repository. We'll use a separate Git repository that was created for this demonstration. We won't be passing a branch, but if we wanted to pull a specific branch, we could pass it here. If we already have secrets created for this repository, great, let's use those. But if we assume that we have not yet created those secrets, let's go ahead and create them now so that we can securely access an external Git repository. Let's name them something that other developers will be able to utilize. For now, let's go with SageMaker Demo Repo Secret. Next, we'll pass in our username and password. Please note that when you enter a password, if you have two-factor authentication enabled for your Git repository, the password should be a personal access token that is associated with your GitHub account. Even if you do not currently use two-factor authentication, we recommend always using a personal access token instead of your account password. If you do not have an access token, you can go to your GitHub account, select Settings, and navigate to the Developer Settings tab. This tab will give you a few options to choose from. You can go to Personal Access Tokens, and there you should be able to determine if you have any access tokens that you can use already. If you don't have any, generate a new one so we can use them over HTTPS. When you generate your token, you'll be prompted to provide details on exactly what it is that token should have access to. Please review this in depth, especially if the code repositories you are cloning are not personal. In order for the token to permit you to clone via SageMaker processes, you will need to provide access to private repositories, but you can pick and choose exactly what you'd like to allow. For more information on how SageMaker interacts with AWS secrets and Git repositories, please view the SageMaker Developer Guide. For now, let's create our secret. Success! We've created our secret. Now we can add our repository. We won't save. And just like that, we now have two repositories that SageMaker is aware of. Awesome. Now let's move on to our final subtopic under the notebook label. Notebook instances. Once we are on our instances page, we can view all of the currently available SageMaker instances in our account. It's clear that we do not yet have any SageMaker notebook instances, but once we create one, we'll be able to see the name of the notebook, the instance type, when it was created, its current status, and the actions that we can quickly take on the notebook. We are going to go ahead and create a new one now. We'll do this by hitting Create Notebook Instance in the upper right-hand corner. Now we're going to configure our notebook instances. Let's start with a name. We'll name this one something simple. SageMaker Demo. As a best practice, always name your notebook something simple, but still descriptive enough to explain the notebook's contents so that other members of your team will be able to decide which code lives in which notebooks. Now we get to determine our notebook instance type. This will be an ML-T2 medium by default, which is one of the lower powered instance types. We'll use this for now, but as we can see, there are a number of different instance types to choose from, including those that are compute optimized or designed for accelerated computing. Please take a look at the specs and prices for each instance before deciding what makes the most sense for your work. Typically, an exploratory data analysis work can be completed using lower spec instance types, but training jobs, dependent on the data size and algorithm, will likely benefit from an instance type with more CPUs and higher available memory. Importantly, this setting is dynamic. As a data scientist, we can create our notebook using the low-cost instance type and then move to a higher-powered notebook once we want to be ready to train the model. This keeps our costs low throughout the model development process. Next, let's take a quick look at elastic inference. Elastic Inference allows our notebook to speed up throughput and decrease latency of real-time inferences at a much lower cost than using a GPU instance for a model endpoint. For more information on SageMaker's Elastic Inference, check out the details in the SageMaker Developer Guide or click the link to learn more. The last configuration parameters we can set within our standard instance settings are lifecycle configurations and volume size. By default, we will not utilize a lifecycle configuration, but we discussed lifecycle configs earlier in this video, and this is where we can implement them within our notebook. Let's add our Git lifecycle configuration by selecting SageMaker Demo Config. Lastly, before we move on to permissions and encryption, we can view the size of our volume in gigabytes. This can be thought of as a working area to perform tasks such as cleaning or storing temporary data, such as validation results. A few key callouts regarding attaching volumes. These volumes are encrypted, which means SageMaker cannot actively determine how much available free space resides on the volume. This leads to the second point. SageMaker supports the increase of volume size when a notebook is updated, but does not support the decrease of volume size. If you require a smaller volume size, create a new notebook instance with the desired size. Additionally, only files and data saved within the /home/ec2-user/SageMaker folder will persist between notebook instance sessions. This means that any data that is saved outside of this directory will be overwritten when the instance is stopped and restarted. Now that we've completed our settings parameters, let's move to permissions and encryption, where we will select our AIM role. This is often a confusion point in the notebook creation process, so let's spend some time discussing how AIM roles are used within SageMaker. We can see that we can use either an existing AIM role that we've created within our account. Those accounts will have the necessary permissions to access SageMaker resources. Or we can create a new one. If we don't already have a role that we'd like to use, creating one is a seamless way to allow SageMaker to create its own role using the naming convention Amazon SageMaker-execution role with an appended datetime. This automatically creates a role that will have the AWS managed policy Amazon SageMaker full access. SageMaker requires us to attach a role due to the fact that it is a managed service that needs to perform operations on the user's behalf. These operations must be permitted by the user. Because this is role-specific and not at the user level, we cannot just select ourselves, so to speak, as the role. We need to select the role itself. If we choose to create a new role, a prompt box will be open for us to verify the permissions we would like to attach. The auto-generated role will utilize AWS-managed Amazon SageMaker full access policy, but we will have the ability to configure the S3 bucket that the role can use. By default, the policy will be created allowing the role access to any S3 bucket within our account. If we want the specific role to only have access to certain S3 buckets, we define that here by selecting specific S3 buckets and specifying the names of the buckets we'd like to use. We'll use any S3 bucket for this instance. It is important to note that the datetime associated with an auto-created role also has the subsequent permissions for specific S3 buckets. Please note that. Now that we have our role defined, we can select Create Role. Success! We've created an AIM role. Now we can decide whether or not we'd like to give our root users access to this notebook. This means that the account's root user has access to the notebook. By default, this will be enabled, but we can choose to keep this notebook from the account's root user if we would like. We'll leave that as enabled for now. Next, let's decide if we want to select an encryption key. By default, SageMaker will not use any custom encryption key from AWS Key Management Service, or KMS. Let's assume that in this case, we have data that may be considered sensitive and therefore is a potential information security risk. If this is the case, we should strongly consider using a KMS. If we already have an AWS key already created, we can select it now from the dropdown. We can see a few options here to choose from. or we can manually enter a key's ARN to attach it. If we wanted to add a KMS here, but did not have one available, we could create one through the AWS KMS service by simply searching for it in our Services tab. If we do choose to create a new KMS key to manage our notebook encryption, please check with your administration team on any standard that has been set. For now, we'll go ahead and use our existing key, SageMaker KMS Demo. Let's move on to network configuration for our notebook instance. When determining what network we want to use, we start with one basic option, VPC or no VPC. A VPC, or virtual private cloud, allows a user to provision off a section of the cloud that is logically isolated. This means an area of the cloud that would be cut off from the broader cloud environment, accessible only through very specific and secured private networks. We, as users, have the option to choose between three main configuration types: no VPC, which is default setting, a VPC attached with internet access, and a VPC attached without internet access. All of these configuration options will configure a network interface on the managed EC2 instance on which your SageMaker notebook is running. Let's walk through each of these options in a bit more detail. First, if we choose not to attach a VPC to our notebook instance, all network traffic will flow through a single network interface that is managed by SageMaker. This allows our notebook instance to have direct access to the internet, thus allowing us to download popular packages or notebooks or further customize our development environment to enable efficient and effective work. So why wouldn't we want to just let our notebook connect directly to the internet? The answer is security. By allowing your notebook access to the broader internet, you expose the notebook to threats via both code or malicious users. Say you download a package you believe is going to help improve your data science development process, but in actuality, there's malicious code that wants to access your data and understand it. The notebook and its resources are now exposed to this malicious code. If we do not want to manage additional resources for that improved level of security, we can choose not to utilize a VPC as our default setting. Let's assume that we know we have sensitive data involved in our data science development process. In this case, we'd want to attach a VPC to our notebook instance as an improved measure of security. This allows us to restrict the traffic that can flow through the public internet. We have a choice whether or not we'd like to allow our access directly to the internet. We'll select our default VPC. Once we decide that we do in fact want to utilize a VPC, we'll be prompted to select two additional configuration parameters, subnet and security group. Let's first talk about subnets. First, what is a subnet? A subnet is a specified CIDR block within your VPC, and more importantly, a subnet resides entirely within one availability zone, which is different from the broader VPC resource, which spans multiple availability zones. If a selected subnet has traffic that is routed to an internet gateway, we refer to that as a public subnet. If we create a subnet that does not have access to the internet, we refer to that as a private subnet. Here we will be using a public subnet so that we can pull down public repositories and packages as we would like. The last thing we need to decide on is our security group. Security groups are essentially a virtual firewall that can control incoming and outgoing. When we specify a subnet and security group, we allow SageMaker to create elastic network interfaces, or ENIs, that are associated with our subnet. ENIs allow our model containers to connect to other resources within our VPC. Since this is desirable behavior in our data science development environment, let's go ahead and select the default security group that is associated with our VPC and subnet. We've now configured a more secure notebook instance, but please do note that there is much more happening within our AWS ecosystem involving VPCs and security. So please be sure to review more in-depth materials made available by AWS, especially the SageMaker Development Guide. Awesome. Now that we've configured our network, let's jump to Git repositories. We've already talked in depth previously about how to add a Git repository to the SageMaker service. But we still have plenty of flexibility within our notebook instance to manage our notebook's interactions with existing repositories. Let's explore those options. We can create our notebook with no repository attached, which is the default configuration. or we can utilize one or more of three potential avenues. We can clone a public Git repository. We can add a new repository to the SageMaker service, which will take us to the same setup page we explored during our pre-work. Or we can choose from a list of already existing Git repositories that our service knows about. Recall that we attached these previously. Importantly, when we added this repository to SageMaker, we also created and linked secrets to the SageMaker service. This allows SageMaker to authorize with GitHub during the cloning process. Let's attach this repo. We can see that we have options to add additional repositories if we would like. So let's do that. As a SageMaker developer, we're always looking to learn from what others are doing and improve our code. A great resource for such exemplary code is the SageMaker Examples repo, which has tons of notebooks exploring many different aspects of SageMaker's functionality, as well as best practices around model building. Because this repo is public, we can just point SageMaker to the repo via our URL, and it will handle the rest for us. So let's add that quickly by selecting Clone a public Git repository and providing a URL. We'll just copy and paste it. Perfect. Now we have a public repository that we can utilize, as well as our private repository. Importantly, our network configuration allows us to contact the internet and successfully clone down these repositories in a secure fashion. The last thing we are going to do before firing up our notebook is tag it. As we've talked about before, we can apply tags as key value pairs to help us understand our resources more acutely. For example, perhaps our team wants to better understand which business units are utilizing which AWS resources. We can use tags to understand this. Perhaps we'll have the key business unit and the value operations. For now, we'll just explore using key my tag and value of tag. And now we can create our notebook. Let's select Create Notebook Instance. We'll be taken back to our SageMaker Instance dashboard, and we can see that SageMaker is working to fire up our notebook for us. We can keep an eye on the status of our notebook to see whether it's ready to be in use. Once we see in service in our status, as explained up here, we are good to go. Wonderful. Looks like we are ready to utilize our new notebook instance. We have the options of using Jupyter Classic or Jupyter Lab. This is purely a developer preference. Use whichever one you like. We'll go with Jupyter Lab for now. Let's select that option. Just like that, we have a Jupyter environment being created for us, managed by SageMaker, secured via VPC, and utilizing multiple repositories to streamline our development efforts and available with the selection of a few configurations and the click of a few buttons. We can see here we're in our Amazon SageMaker Examples repo. This is the public repo that we attach to our notebook instance during configuration. If we navigate up the folder directory, we can see our SageMaker demo repo. This is our private GitHub repository that we're accessing via AWS secrets. Wonderful. Both public and private are available to us. Now, before we go, let's talk about how we would stop a notebook. Because we're charged for the amount of time our SageMaker notebook instance is running, be sure to pay attention to notebooks that are not in use and can be stopped or ultimately deleted. Let's pretend that we've gone through our data science development exercises and we no longer need this notebook to be running. In order to stop our notebook, we're going to navigate back to our SageMaker instance's dashboard. In order to stop the notebook, we need to perform a stop action. We'll do this by selecting the specific notebook we want to stop. In this case, it's just our demo notebook. We'll click the selection circle on the left-hand side. We now notice that our Actions dropdown is active. Let's select our actions and hit Stop. Once we do that, we can see our status move from in service to stopping. Once the status changes to stopped, we know that this notebook is no longer consuming resources. At this point, we can decide to leave the notebook in a stop state, or we can delete it from SageMaker entirely. We can see that our notebook is now stopped. If we do decide to delete the notebook, that is permanent and cannot be undone. We'll go ahead and clean up our SageMaker service since we do not need to utilize this notebook going forward. we'll go back to our Actions dropdown and select Delete. We'll see that SageMaker will warn us about the deleting notebook. It cannot be undone, and it may affect other resources. We do still, in fact, want to delete this notebook, so we'll confirm by hitting Delete. Before hitting Delete, be sure that this is the appropriate action. We can see that our status is now moving to deleting. SageMaker is removing the notebook instance for us. Once the deletion is complete, the line item will be removed from our notebook instance table. At this point, our notebook has been created, stopped, and deleted, all with the click of a few buttons. We've learned how to configure our notebook instance. We learned about execution roles, lifecycle configurations, VPC attachment, Git repository attachment, and more. We're now ready to develop data science solutions using SageMaker. Happy developing!